All right, folks, it's back in action here. In this video, we're going to go through two more skills that you can use when you're trying to simplify identities. And the first one that we're going to look at, if you've got my foldable, is going to be in the middle of the yellow foldable. Otherwise, just follow along. This is an important one as you're working through any identity at all, and it's that you need to make sure that all of the angles in any problem that you're working with are actually the same, okay? So if the problem has multiple different angles in it, you need to ensure that those are the same before you move on to any other skill. Now, often they'll just be thetas, so if you're scanning around, it might be thetas, they might all be x's, so you don't have to worry about it. But if they are actual angle measurements, you do want to make sure that they're the same. Now, if the measurements that you're given are different and complementary, that is a clue that you can use the complementary cofunction theorem to rewrite it. If the angles are not different and complementary, then there's probably another way to look at the problem, possibly in terms of reference angles or something like that. But the ones that we're going to look at here are all going to utilize the complementary cofunction. So let's take a look at this first problem that I have here. We notice that we have two different angle measures, and what you need to do is you need to just choose one that you want to keep. So let's say that I wanted to keep that 40 degrees, so my denominator would stay the same as a cotangent 40. Then the numerator is going to need to be rewritten. I'm going to change that 50 to its complement of 40, and then I'm going to change the tangent to its cofunction, which is cotangent. When I do that, I see that, oh, cotangent 40 over cotangent 40 simplifies to just 1. Now, let's say that you had decided, oh, I didn't want the 40, I wanted the 50. You would have kept your numerator the same as a tangent 50. Then your denominator, you'd change the angle from 40 to a 50, changing to its complement, changed the cotangent to its cofunction, which is tangent, and then you would have tangent 50 over tangent 50, which would get you to the exact same answer. No big deal. On the next one, what we're going to notice is we've got a 20 degrees, a 20 degrees, and a 70 degrees. So it's going to make the most sense to change the 70 since we have two that already match. So we're going to keep the cotangent 20. We're going to keep the cosine 20. Then on this cosine 70, we're going to change the 70 to its complement of 20. We're going to change the cosine to its complement of sine. And now we can see that cosine divided by sine is cotangent. So what we have here is a cotangent 20 plus a cotangent 20. And of course, cotangent 20 plus cotangent 20 is 2 times cotangent 20. So that would be another one. On our next one, we're going to have, again, we've got different angles, but we recognize that they are in fact complementary. So we're going to choose one to keep and one to change. Doesn't make any difference which one we did. So let's say I want to keep the 80. So I have cosine squared 80. Then on the next one, I'm going to change the 10 to an 80 and the cosine to its cofunction of sine, so sine squared. So I'm going to have cosine squared, oh, and I just realized that I wrote a minus there and not a plus, sorry about that. So then I'm going to have a cosine squared plus sine squared. Well, I know that cosine squared plus sine squared is simply 1. If we had done the same problem with the 10 degrees, just like we saw back here on number 1, we would still get to a 1. We would still get to a 1 on that one if we had worked with the 10 degrees instead. Now, on this same foldable, on the upper left, I've got a few more problems that we can look at, and that's going to allow us to look at another skill, and I consider this kind of like my hammer skill. This is my, if I don't know what else to do, I'm going to come back to this one, and that's going to be rewriting everything in terms of sine and cosine. So When I look at this, I don't have anything squared. I don't have any addition, subtraction with ones. So I couldn't use any of the Pythagorean identities that we had looked at in the other video. So what I'm going to do here is I'm just going to rewrite everything in terms of sine and cosine. That's kind of the simplest way to do it. So cotangent is cosine over sine. So I'm going to rewrite this as a cosine theta over a sine theta. Always remember to keep writing those thetas. Secant theta is 1 over cosine theta. Don't get lazy and drop the thetas. Now I can see that since I'm just multiplying two fractions, what I could do is I could now cancel. So these cosines will cancel. So that would leave me with a 1 over a sine theta. Well, I know that 1 over sine theta is cosecant theta. Now, typically, we don't leave things as fractions if we can avoid it, so that's why we convert from the 1 over sine back to the cosecant. On the next problem, what we're going to see that first thing is that I've got this theta plus pi. So I need to remember my periodic properties for tangent, and I need to remember that a tangent of a theta plus pi is really no different than just tangent theta. So that one just gets rewritten, no big deal. Now I'm going to rewrite in terms of sine and cosine. Cosecant theta is 1 over sine theta. We just saw that in the previous problem. Tangent theta is sine theta over cosine theta. This looks very similar now to the last problem. The sines will cancel. So I get 1 over cosine theta, and 1 over cosine is secant theta. Now, I want you to notice that I just wrote a little arrow here. I want you to get in the habit of using arrows and not equal signs. Equal signs start to imply that it's an equation, and students then move things back and forth. So what we want to do is we want to do some type of a simplification and then an arrow to just indicate that we're going from this idea to the next idea. On the next problem, when I look at this, I have a big red flag. I notice, whoa, my two angles are different, okay? Not only are they different, but they're not really complementary right now either. I've got a couple problems going on. I've got different angles, and I've got this negative here. So this negative, remember, cosine is an even function. And since cosine is even, then cosine of a negative 27 is no different than cosine of a positive 27. So I can actually just flip that to a positive. Now I have different angles that are different and complementary. So I can choose to rewrite this. I'm going to keep that 27, and I'm going to rewrite my 63 as its complement. So the 63 is going to change to a 27. The cosecant is going to change to its cofunction of secant. So I'm going to have secant 27 times a cosine of 27. Now, you might already see how that's going to simplify since secant and cosine are reciprocals of each other. But if you don't, we can rewrite this in terms of sine and cosine. Secant 27 is 1 over cosine 27 times a cosine 27 over a 1. So sure enough, you can now see how those cancel, and that is going to lead us to a nice simplified answer of a 1. Okay, and then there'll be one more video that we're going to look at, and that's going to be what do you do if you've got things that are being added and subtracted that aren't Pythagorean identities, and then also multiplication and some more multiplication and division.